Welcome back everyone to Data Science for Everyone. Today we're going to be looking at the Bitly data analysis example with pandas. Let's get started. So the data that we're going to be using is from Bitly. Okay, so it's a URL shortening service provider. And again, it's going to be used, they partnered with the US government a while back to provide free anonymous data gathering. And again, there's a hack quite a few years ago as well, if you guys may know that. But what this is actually doing is this is an hourly snapshots of some of the data. Now each line of the data is going to be, well, let me actually just kind of show you this real quick. And so we can do something like shell, and we'll do the whole line here will be, oh, actually we know we can do this as bash. And we'll do ls data bitly.txt. You know, we'll do head instead. So you can see here that this is actually a little bit of the snapshot of the data. Okay, now this is a JavaScript object notation, so it's a JSON file. Now this happens to be saved as just a .txt file. It's a very common way for us to look and utilize data, particularly whenever we're looking at internet compatible data. Okay, it's very, very common. Now what we're going to be doing with this is we want to actually go on, and you can see here that in some of this data here that they have time zone data. So we want to go on and try and count the time zones. So let's go on and look at how we can maybe import in this data. Okay, so there's going to be a couple different ways that we can do this, but I'm going to go on and clear this out because it looks messy. And let's do import pandas as PD. Well, this is what we're primarily going to be using today. We also want to do something like how are we going to want to actually go about reading this in? Let's go on and read it in. Well, let's see how it looks if we just import it in with the JSON reader. So let's call this df is equal to pd.read JSON, and we'll do data bitly.txt. Let's see how that actually reads in. It probably doesn't like it very much. Trailing. There's some trailing data. Okay, and so what we'll do is let's go on and actually write up a little bit of a function to do this. Sometimes, again, you need to take care of JSON data in a little bit different way. So let's create up a path variable in here, and the data is in data.bitly.txt, so we don't have to write it out too often. And let's go on and do. Let me put this up here too. Let's keep everything clean. Import JSON. And we want to create up a record. Records is equal to JSON.loads, because we're going to be loading in the data for line in open path. Okay, and so what we can actually do here, let me even show you this is what this open path actually does. So I can do something like open path dot read line. And so it'll go through and it'll read the first whole line of that data set. Okay, and notice here you can see that it's this \n, that means new line, so that's what it's going to be grabbing, each of those new lines, and it's going to be putting them inside of a list format, okay, as it loads it in for me. So I'm going to go on and delete that line, and we'll run this. And so you can actually kind of take a look. So if we do records of 0, let's grab that first line. So notice here that it's actually that same exact thing that we did, but since we've used this JSON.loads, it is now actually cleanly formatted, and it's not in that new line type order. Now we can do this with our import read JSON, but we have to do a little bit of finagling, and I kind of feel more comfortable with this way. Again, it's a little bit more of the old school type way. But again, that's okay. It's okay to be old school from time to time because it means that we kind of know several different ways of accessing the data. So let's go on and take a look then at actually importing the data. So let's do df is equal to pd.dataframe. We're going to convert this to a data frame of our records. df.head. Okay, and notice here now we have all of these different variables, and let's take a look at each of the variables in turn. So df.info here, and we can see here that we have a lot of data. So for example, we have A, C, and K. TZ is our time zone that we're going to be interested in. So specifically, let's go on and take a look at the time zone itself. So df.tz.head. Okay, and maybe let's do top 20. So notice here that we actually have quite a few different types. So we have America, New York, America, Denver, America, Sao Paulo, Europe, Warsaw. We actually have some missing data. And again, if we go back up here, you can see that there are 3,040. Okay, and notice here our index range here is 3,560. So there are definitely some missing values in there that we'll have to deal with as well. And we have all different other types. So let's go on and look at maybe the first way that we can go about showing this output. So let's look at time zone counts is equal to our data frame tz dot value counts is one of the first ways that we can do it. tz dot counts dot head 10, and here we can see that we have our counts. So again, we have a lot of blanks in here. That's going to be a bit of a problem for us. Everything else looks relatively clean, as we can see here. Now we can go about maybe visualizing this as well, using a plot or something like that. We can also do a bit of data munging, and let's fill in some substitute value for the unknown value. So let's deal with the NAs first. And so let's do this, okay? So first off, we actually have we don't know what the difference between an NA value is, or let me do this. We can also do the tail real quick. Okay, so we do have some that have some ones. Now that's also this value counts is not going to deal with the NAs. Okay, so what we need to do is do two things. We need to clean our data. So clean our time zones in here is our data frame tz dot fill NA, and we're going to call this just missing. Okay, now the next thing we also need to do is clean tz, and we want to create up a we need to subset this, okay? So where it's clean tz is equal to just some empty string, okay? And we'll set these equal to unknown, okay? Because I'm pretty sure that these here are going to be just blank, okay? Because that's what they're actually looking at there. So we'll change that to unknown. Now if we, equals, okay? And let's go on and actually double check that. So let's do clean tz dot value counts, and I'll do tz counts value counts, and then we'll do tz counts dot head of 10. And notice here now we actually have that unknown. So those were definitely unknown. They were just blanks. They were not missing values at all. So let's also go on and plot these out. Okay, now a couple different ways that we can do this. We can go on and do this with tz counts dot head of 10. Let's say dot plot kind is equal to bar. Okay, but this is definitely not pretty, is it? Okay, so let's go on, and I'm going to come back up here, and I'll do something like import Seaborn as SNS, so we can use our nice Seaborn plots. And let's go back down here, and let's take this very bland looking data set, and let's actually play with it, okay? So let's do sns.barplot, and we want y is equal to, you know what, let's do this. We'll do subset is equal to tz counts dot head of 10, and we'll do subset dot index, and then x in this instance is subset dot values. So then now we actually get a nice looking bar chart in here, okay, where we have our unknowns, we have our New York, Chicago, Los Angeles, Denver, our missing values, London, Tokyo, Honolulu, Madrid. So these gives us our nice top 10. Okay, and maybe we would want to give it some sort of header or anything else. We can always do that a little bit later on. Now, there is a field that contains a little bit more value for us in our data. So this is information from the browser, okay? The device and the application that's used for shortening that URL. And if we take a look then, and that's this A value. So df A, and let's look at 0. No, not 0. We want 1, let's say. So here, for example, it's Google Maps, Rochester, New York. Let's look at maybe a couple more. Let's look at 100. Okay, and that's a Windows, Gecko, Firefox. Maybe there's something else. Let's try 50. So Gecko, Firefox, same thing. So again, you can see that there's quite a different types of things that we can do. So maybe we can use this to gain a little bit of insight. Let's parse this out and gain some agent information. That's what that A actually stands for, is the agent, the actual individual. And let's see, one possible strategy, maybe let's split off some of the data, okay? So we want to grab maybe just this first part here, like this Mozilla 5.0. What was some of the others that we looked at? We looked at this one here, for example. Maybe we want to just keep this whole section here, all right? So maybe we want just to split it on that first space. Okay, so let's give that a try. So our results here is pd.series x.split, and we want to keep the first split. And now remember, split itself, its default is a space, okay? So we don't actually need to put the space in here, but if you wanted to split it on something else, okay, like the / or anything else, you would need to put that in here. For x in df of a dot drop in a. And let's look at our results here, res.head. Okay, so we can see that, maybe let's see a little bit more. So again, a majority of these are kind of telling us where they were using them from, whether they're using Mozilla, Opera, or whether they're using like a Google Maps app, that type of thing. So let's actually take a look and see what we can see here. So res.value counts in here, and let's do the top 10. So definitely Mozilla is going to be our top in here. This is our percentage-wise in here. Mozilla, Google Maps, Opera, some test internet agent, Google Producer, some Blackberries. Again, you can definitely see here that these Blackberries. You can see that this is an old data set. Now suppose we want to kind of decompose our top time zone data into maybe like Windows users and non-Windows users. Okay, and so we actually have that data with the OS, and so let's do let's call this data frame C in here, because we actually want the new data. Let's just do data frame 2. Is going to be data frame, and we want data frame of A that are not null. Okay, so we want we're basing this off of our agents. Okay, so we have to have this information from our user. Okay, so we'll grab that, and then we want to go on and check our operating system. So, for example, if we look at df of a dot head, okay, so notice here that they have, for example, Windows, Macintosh, and here it just says compatible, but it also has Windows in there. Maybe we do top 100 for now. That's not going to give us a lot. Here's iPad, that type of thing. So let's actually just split this up into, maybe, because there's also probably some Linux in here as well as whether some other mobile devices probably. But let's go on and split this between Windows users and non-Windows users. Okay, so what we can do with this then is df2os for operating system is mp.where df2a dot string dot contains, because this is going to give us a true or false value for Windows, not widows. And then we want it to give us a Windows or non-Windows option. Oops, and I have not imported NumPy. So import NumPy as MP. Now I'm keeping all of this at the top so that whenever I hand this off to someone, they're going to have all of my imports as we go along. Now I'm doing this, I kind of know what I'm going to be using usually, but I'm kind of showing you what I would do if I just was doing this kind of off the bat, kind of off the top of my head. So let's go back down and let's rerun this now. Okay, it's just giving me a bit of a copy warning, and that's okay for now. So let's go on and look at df2.os.head. So now here, notice we have Windows, non-Windows users. So now we can go on and actually group by, which is going to be kind of fun. So we can say by time zone OS is equal to our df2.group by here, and we want our time zone. We also want our OS. And then we can go in and use some of our aggregate functions to do ag counts in here, and that's by tzos dot size. And the size is to actually do a count, okay, by the groupings, dot unstack fill NA with zeros. Dot NA. Okay, and then let's go on and take a look at this. So here we definitely have our total counts here of our Windows users and our non-Windows users. We have so for example, Africa, Cairo, Casablanca, again, all kinds of things. A lot of them we do see a lot of zeros in there. We have some fours and whatnot by each grouping. Another thing that we can do is we can create up a bit of an indexer in here. So an aggregate indexer is equal to our ag counts dot sum of one dot arg sort. And so we can look at that indexer here, and you can see that we've taken care of each of these. And now this is going to be constructing an indirect index for the rows so that we can actually keep things a little bit clean. So let's go on and do something like count our sub index, and we'll do, we'll take off the top 10, let's say, and do ag counts dot take indexer -10 through the end, and then count sub dot head. Here again we have our OS and our others. We look at Sao Paulo, Madrid, Honolulu, Tokyo, London. Now Pandas has a very nice method here called inLargest, which basically is going to be doing the same thing that we just did here. And so let's actually look at this. So maybe we want the largest one. So we can do ag accounts.sum of one dot in largest, and we want the top 10. Okay, and notice that's going to give us some other answers that we have as well. And again, these are going to be formatted and actually sorted in the proper order. Now, the last thing that we're going to kind of want to do here is to go on and plot a nice bar plot to see how things look. Okay, and I'm going to go on and use this this count sub in here, I think. So count sub is equal to our count sub dot stack. And then we want the count sub dot name is equal to total in here, and then we want count sub dot reset index in place is true. Whoops. Oh, okay, because it's not actually a data frame, it's a series at that point. So let's do count sub is equal to. What happened here? Did I... Let me double check here about this one. Count sub here. Why does it... Maybe I didn't need to stack it. Hold on. Count sub. I'm going to redo that. And let's look at count sub here. Okay. I'm going to delete that one. And let's go on and set up a sub here, and let's do something like dot stack. What does that actually look like for us? All right, that's not exactly what I'm gonna want, but it's gonna work. And so let's do count sub. So then let's look at count sub dot head. Okay, and then we want to go on and why did it do that? Okay, let's go on and keep moving forward with this, and let's do dot name is equal to total count sub dot head. All right, that gave us that name, but I did not want... All right, so let's do count sub dot reset index. All right, that worked. And we should be able to do now in place is true. Why not? All right, let's not worry about it. So this and this is going to be, let's actually just overwrite it again. Count sub is equal to this. Count sub. Okay, so now we actually have our time zone, our OS, and our total. And let's go on and plot out you want to do them all? Let's go on and do them all. So we want SNS.barPlot. We'll do x is equal to total. We want y is equal to our time zone. Our hue is equal to our OS. Data is equal to our count sub. Okay, and so now we actually have our nice plot. Now this plot doesn't really make it easy to see the relative percentage of Windows users. These are just the counts compared to smaller groups. So maybe it's better for us to normalize so that the percentages of the sum are equal to 1. So let's do a little bit of a normalization. So define norm total of the group. And this here we would do whatever group it is dot normed total is equal to the group dot total divided by the group dot total dot sum. And then we want to return the group. So our results now are going to be our count sub dot group by our time zone. And then we want to apply in here our norm total. So now we can actually do SNS.bar plot. We want X is equal to our normed total. Y is equal to our time zone. Our hue is equal to our OS. Data is equal to res. Whoops, and there. Okay, now we actually get everything as a percentage. Now we could have computed the normalization a little bit more efficiently if we wanted to. And again, we could have used, for example, just some transformations. But that's just another way to do it. Okay, there are several ways that we can get the same results, and that's kind of the beauty of programming with Python. So I hope you guys like this example that we've ran through today. If you do like this, please comment, subscribe, and definitely punch that like button. And I will see you guys next time. Bye-bye.